Okay, so now let's talk about confidence intervals. Right. When we don't know the population standard deviation, so sigma x is unknown, right? Now remember that if we know the population standard deviation, in order to construct confidence intervals, we will use the formula x bar plus minus z sub alpha over 2 times sigma x divided by root n. Okay. Now the problem with this formula is that in most, if not all, applications, we do not have access to the population. Okay, so we can't obtain sigma x, right? Imagine if we had access to the population, you would just go ahead and calculate the population mean immediately, right? You wouldn't bother spending time constructing confidence intervals, okay? So because of this drawback, we have to find another way to calculate confidence intervals when we don't know the population standard deviation, okay? So if we don't know sigma x, in order to construct confidence intervals, we will use the following formula. So x bar plus minus t sub alpha over 2 with n minus 1 times sx divided by the square root of n. Okay, where alpha is still equal to 1 minus the confidence coefficient. Okay, Sx is the sample standard deviation. Okay. And T sub alpha over 2 with n minus 1 is the T value, or the T squared, such that the area to its right is alpha over 2 and n minus 1 is the degrees of freedom. Okay, so now what is this T thing? Okay, so let's talk a little bit about the T distribution. First off, the T distribution is a normal distribution. Okay, so it has a bell-shaped histogram, right, with the mean of 0 and the standard deviation of 1. Okay, so far it looks like the standard normal, right? It looks like Z. However, it is not Z. Okay, the T distribution is distinguished by the degrees of freedom. Okay, and the T distribution approaches the standard normal as the degrees of freedom gets large. Okay, in other words, remember that the degrees of freedom is equal to n minus 1, so 1 less than the sample size. When we say that the degrees of freedom gets large, essentially we're saying that the sample size gets large. Okay, so now let's look at the formula. Suppose we have a sample, right? In order to use the formula here, right, we need to calculate the sample mean. That's easy, right? We know how to calculate the sample mean. We need to calculate the sample standard deviation. Okay, maybe it's tedious, but that's something that's doable, right? And given the sample, we know what the sample size is, so we know what n is, and we know the square root of n. Okay, so in order to use this formula, the only thing that we need to find is this quantity. Okay, and we find this quantity by using the t table. So let's look at the t table. Okay, so here's what the t table looks like. In the first column here, right, you have the degrees of freedom. So the degrees of freedom goes from 1, 2, 3, 4, 5, all the way to 30, and so on and so forth. Okay, so for each degrees of freedom, you have a different t distribution. Okay, in the first column here, right, you have the area to the right of a t-score. Okay, so in other words, given a value to the right of the t-score and given a degrees of freedom, you can go ahead and find the appropriate t value that you want to use. Okay, so let's go ahead and look at an example. Okay. Suppose you want to find the 90% confidence interval. Okay, we know at this point that alpha is equal to 1 minus 0.9, which is 0.1. Okay, 0.9 is the confidence coefficient. Okay, and so alpha over 2 is 0.1 divided by 2, which is 0.05. Okay, and suppose we have a sample size of 24, which gives us a degree of freedom of n minus 1, which is 23. Okay, so to find t sub alpha over 2 with n minus 1 degrees of freedom, which in this case is just t of 0.05 with 23 degrees of freedom, you would go to row 23, right? This is the degrees of freedom, so you go to the row labeled 23, then you look under column 0.05. Okay, so you look under column 0.05, and the value that you're looking for is right here. Okay, so it's 1.714, and so you would just plug this t value into your formula, into this part right here, right, and then calculate your confidence interval. Okay, so let's look at another example. Okay, suppose you want to find the 99% confidence interval. Okay, so alpha is 1 minus 0.99, which is 0.01. So alpha over 2 is 0.005. Okay, Suppose we have a sample of 15 observations, right? So the degrees of freedom is n minus 1, which is 14. And so in order to use a formula, we want to find t sub alpha over 2 with n minus 1 degrees of freedom, which is t sub 0.005 with 14 degrees of freedom. So to find this value, you would go to row labeled 14, right? So this row right here, and then you would look under column 0.005, which is this column, right? So you would get a value of 2.977, and that's the value that you use to plug into the formula. Okay. Now it is very important to know how to read the table. Okay. So because if you can't read the table, you can't construct the confidence interval. Okay. So if you have any questions at all about how to read the table, please let me know. Okay.